Hello, everyone. Now we're starting a exciting section about another problem. So far, the only problem we faced while trying to compute limits algebraically is putting your number in or your infinity in and getting the square root of zero. So square root of zero is bad. You need to go left and right. Now, the second bad form, which is like very, very similar to square root of zero, like it's a case that I also call the indeterminate boundary 2, which is division by zeros. And these two cases are very similar. Okay, so when you are dealing with an indeterminate boundary, oh my God, I have such a hard time saying it. Thank you, no braces. Okay, so when you have like a indeterminate boundary, the approach is exactly the same for all of them. So there's three of them that we'll see in this class. So one is the square root of zero. The second one is division by zero and ln of zero that we'll see later on. And we need to do stuff. Okay, so it's not. So what do you do if you have, one over zero? Well, if this is a two-side limit, just like this, this is exactly the same as square root of zero. So if it's a two-side limit, you need to define the left and the right. And then for those one-sided limits, on the left, you evaluate at a minus, just like you did for square root of zero, which is, of course, a minus a number that is smaller than a. And on the right, you evaluate at a plus, which is a number slightly bigger than a. And then there's two possible cases. Either your expression where you have a division by zero will simplify to 1 over 0 plus, and then one of those basic infinite law tells us that this blows up to infinity, or you're going to get 1 over minus, and this will blow up to minus infinity. So when you have a division by zero, basically on the left or right side, you're going to get plus or minus infinity. Okay, and then, of course, if it's a two-sided limit, you just compare are both side plus infinities or both side minus infinity, and then the two-sided limit is equal to either plus or minus infinity. And as soon as they are different, then the limit does not exist. Anyways, the best way to do this is to first look at an example. Let's compute the limit as x goes to 3 of minus 1 over x minus 3 squared. So again here, the first thing you do is you plug your number. So you plug 3 in, you hope for the best. Of course, guess what? It's going to crash here. So 3 minus 3 squared is going to be 0. And 1 over 0 as soon as you get something over 0. And here I should be a bit more careful because we'll see other type of problem. But this type of limit is really division by zero in the sense that the numerator is any non-zero number. So here, to be in that case, the top needs to be a non-zero number. So when I say a division by zero, I really talk about only the denominator equal to 0. If you have 0 over 0, this is bad squared, okay? But for this case, it's just a regular division by 0. So what you do, so it's very similar, like division by 0 or square root of 0, it's the exact same thing. So you go left and right because this is a two-side limit. So first you define them. So limit, I like to start on the left side. That's just me. I think most web work questions are actually defined left or right first. But anyway, so you first, and I like to write them up, especially for a test. If you don't do anything other than showing me that you need to study the one-side limit first, you're going to get a lot of partial marks. Okay, so this is really the technique for any indeterminate boundary. So square root of 0, division by 0, or ln of 0. You need to tell me, I know what to do. I need to go left and right, okay, and study these limits. So here we go. So let's do the left first. So I evaluate here at 3 minus. So 3 minus, remember, is a number smaller than 3. For example, I could choose like 2.99. So if you have 2.99 minus 3, you're going to get a number that is slightly less than 0. So you're going to get 0 minus, but you're squaring it. So if you have a number close to 0, like, for example, minus 0.1, when you're squaring it, it's going to become plus 0.1. So you're going to get minus 1 over 0 plus, and minus 1 over 0 plus, that's minus infinity. So that's my left limit. So I have minus infinity Here we go. And then I do the exact same thing on the right side, but I evaluate now at minus 3 plus, so you get minus 1 over 3 plus minus 3. So numbers slightly bigger than 3. Like for example, you don't need to write these little number in orange here. It's just for me, sometimes it helps me understand what's going on algebraically. So 3 plus minus 3 will be very close to 0, but bigger. So you're going to get 0 plus, and 0 plus squared, if you have like 0.1 and you square it, you're going to get plus 0.01, so something very close to 0, but still bigger. So guess what? You're going to get again minus 1 over 0 plus, which is again minus infinity. And of course, these two things are equal. So because they are equal, then the two-sided limit, so they are equal. Then the two-sided limit is going to be minus infinity also. So therefore, the limit as x goes to 3 of minus 1 over x minus 3 squared is equal to minus infinity. By the way, this is not the point of this question, but when you get a limit that goes to plus or minus infinity on the left or right side, you know that this function has a vertical asymptote. But here we have more information. We know that it's a vertical asymptote, and on both sides, the function goes down forever. Right, next example, let's compute the limit as x goes to minus 1 of 2 over, whoa, this is actually a typo here. Let's change this to minus, it's supposed to be plus 1 here. So let's change this 3 here into, if not, there's no problem there. Okay, so let's say we have the limit as x goes to minus 1 of 2 over x plus 1 cubed. So if you plug minus 1 with this brand new updated version, you get 2 over minus 1 plus 1 to the power 3, which is 2 over 0 cubed, which is 2 over 0. And of course, this is bad. Okay, so this is a division by 0 bad. So right away, let's define and compute the left and right limit. Limit as x goes to minus 1 minus. And like I said, my advice, if this is a two-side limit, just show to me that there's two limits to compute here. And then, so the left and the right limit. So just write them down first and then do them. Okay, so the first one, you get 2 over minus 1 minus plus 1 cube. Be careful, minus 1 minus a number slightly less than minus 1 would be, for example, minus 1.01 plus 1. This will be a number slightly less than 0. So you're going to get 2 over 0 minus cube, and 0 minus, for example, minus 0.1, if you cube it, you're going to get minus 0.001, which is a negative number. So here you're going to get 2 over 0 minus, which gives you minus infinity. By the way, for those division by zeros, when it's just a pure non-zero number over 0, the left or the right limit is always plus or minus infinity. All right, what about the next one? Now I'm going to replace it by minus 1 plus. So you get 2 over minus 1 plus. Whoa, just want to plus 1 cube. So minus 1 plus a number slightly bigger than minus 1. For example, minus 0.99, that's slightly bigger. So when you go plus 1, you're going to get a number slightly bigger than 0. So 0 plus cube. When you go 0 plus cube, you're going to get 0 plus again, and 2 over 0 plus is now plus infinity. And of course, when you compare, left limit is minus infinity, right limit is plus infinity. So these two are not equal, and because they are different, this means that the limit, so therefore the limit as x approaches minus 1 of 2 over x plus 1 cube does not exist. Okay, so, but again here I find just a small remark here. Who gives a shit about, two-sided limits. Like the one-sided limits, they tell you everything. On the left side of -1, the function will go down forever. On the right side, it will go up forever. There's a vertical asymptote, and we know completely what's going on here with this function. We know it crashes at -1. This function is not defined at -1, but we understand how it crashes. In this case, we have a vertical asymptote, and we know the shape of that vertical asymptote. All right, another example, one that I like actually. Limit as x goes to 1 of 1 over the square root of 1 minus x. So this one is really special. Okay, so if you put 1 in, you get 1 minus 1, 1 over 1 minus 1 inside the square root. 1 minus 1 is 0. Ooh, this one is really bad in the sense that either you catch it right away. Oh, this is like a square root of 0 problem. That's bad. So if you have a sharp eye, you see that the initial problem is a square root. But suppose you're, hanging over and you forget about square root of 0 and you continue. Well, the square root of 0 is 0, but guess what? It does not matter here. You cannot escape your fate. Okay. This is so bad in so many ways. But the good news here is that even if you don't see the square root of 0 as being bad, and you catch it as as a division by 0 problem, both bad indeterminate forms are solved the same way. You need to check and compute the left and the right limit. So let's do it. So let's compute the left. So first, let's define first the left limit of 1 over the square root of 1 minus x, and define the right limit. So limit as x goes to 1 plus of 1 over 1 minus x square rooted. Again here, just defining the two limits shows me that you understand what type of problem you're dealing with and what you have to do to solve it. And this is always the most difficult part with a limit, is to identify the bad problem and execute the correct solution. Because if you do a different solution on a different type of problem, you're going to have like a hard time. Okay, so anyway, so here, let's plug 1 minus inside. So you're going to get 1 over 1 minus 1 minus under square root at the denominator. 1 over 1 minus is going to be 0 plus. So you're going to get 1 over the square root of 0 plus. So here you have to be careful because we know the square root of 0 plus is normally just going to 0, but if you write 0, you're still dealing with the bad division by 0. So here we have to actually compute the square root of something very small. Like for example, if you take 0.1 and you compute the square root, you're going to get 0 point something, so a number is still close to 0, but bigger than 0. In other words, you're going to get 0 plus again, and then 1 over 0 plus is infinity. Now what about the right limit? So you get 1 over the square root of 1 minus 1 plus. 1 minus 1 plus will be 0 minus. But now you're done because the square root of 0 minus, we know it's undefined, so the whole expression is, the limit does not exist because it's undefined. These two limits are obviously not equal. One blows up to infinity, the other one is not even defined. So therefore, the limit as x goes to 1 of 1 over the square root of 1 minus x does not exist. I love this question on the test, especially like I like to either just give the left or the right. So like when people come out of, hey, on my question I got infinity, and the other guy say, oh, I had undefined. Well, you had different versions. So anyways for that section. So again here, just before I close that section, so if you have an expression, so a limit that is such that the expression goes to a non-zero number over 0, the way you solve it is exactly the same way you solve a square root of 0 by looking at the left and the right limit, plugging in a minus or a plus for the left or the right limit respectively, and then do your algebra with these a minuses, a pluses, and simplify it down, and use basic infinite laws to finally have a conclusion for those limits and then compare if it's a two-sided limit. But anyways, for that section, that's it. Bye-bye.